The diagram below is a scale drawing of a hopper tank used to store grain. An estimate is needed of the capacity or volume of the tank. The figure of the man standing beside the tank allows the scale of the drawing to be estimated. Give an estimate in meters of the height of an average adult man. Well, I just looked this up. 21-year-old Irish male has on average a height of 1.775 meters. This number is about 1 3/4 meters. In feet and inches, it is 5 foot 10 inches. I will just round this number to 1.75 just for convenience. 1 3/4. We want to use the answer in part A to estimate the dimensions of the hopper tank. So let's start by looking at this dimension here. How many little squares make up a distance of 1.75 meters? We have 1, 2, 3, 4, 5, 6. 6 squares here, and here we have 1, 2, 3, 4, 5. So this distance is a bit less than this. It's actually, this distance here would actually be 5/6 of 1.75. See, 6 squares is 1.75, so 5 squares will be 5/6 of 1.75. So we have 5 times 1.75 is 8.75. We divide by 6, so we get 1.45. I'll round this to 1.5. So 1.5 is good enough for this distance here. Okay, let's take this next dimension. Let's count the full squares. We've 1, 2, 3, 4, 5, 6, 7, 8 full squares, and then we have a little bit left over here and here. So we'll put those bits together to make half a square. So we've 8.5 squares. 6 squares is 1.75. So just write down 6 squares is 1.75 meters. Let's get 1 square. We just take 1.75 and divide by 6. To 1 decimal place, this is 0.3. So we have 8.5 squares here. 8.5 squares is 8.5 times 0.3. That's 2.55. So I will write 2.55 meters for this dimension. What about this one here? Well, this looks like 3 full squares. Tiny bit left over here, and there's a little bit left here. I'll just say 3 full squares. It's very close to 3 squares. So 1 square is 0.3 meters. So 3 squares is 3 times 0.3, which is 0.9 meters. Across here we have 1, 2, 3, 4, 5, 6, 7, 8 small squares. So that's 8 times 0.3. That's 2.4 meters. Taking the tank to be a cylinder with a cone above and below, find an estimate for the capacity of the tank in cubic meters. Well, the dimensions are in meters, so the volume or capacity is going to be in meters cubed or cubic meters. Okay, let's look at the cylindrical part of this tank. The cylindrical part has a height of 2.55 meters. So we're just going to look at a cylinder now, whose height is 2.55 meters. And the radius, well, the circular cross-section has a diameter of 2.4 meters. So the radius of the circular cross-section is half of 2.4. Half of 2.4 is 1.2 meters. So once we have the radius and height of a cylinder, we can get its volume. Its volume is the area of the cross-section, which is pi r squared. That's the area of a circle times the height. So here's the formula. We just plug in the values. We have pi times 1.2 squared times 2.55 for the h. So we just bring up pi times the radius squared times the height. So I will write this down to about 3 or 4 decimal places. Let's say 3 decimal places. 11.536 meters cubed. Now let's look at the top part of the tank, which we take to be conical, that is in the shape of a cone. Well, it's very nearly in the shape of a cone. It doesn't taper to a point, but close enough to a point, so that we can take the height of this part to be 0.9 meters. It's the height of the cone. And the radius, well, the radius is the same as the radius of the cylindrical part, which we know is 1.2 meters, half of 2.4. The volume of a cone is 1/3 pi r squared h. It's actually 1/3 the volume of a cylinder that would exactly contain the cone. So we've 1/3 times pi times 1.2 squared times the height, which is 0.9. So we have 1/3 multiplied by pi multiplied by 1.2 squared multiplied by 0.9. So I will write this down to 3 decimal places. This is 1.357. 2 or probably even 1 decimal place may be adequate here. Finally, we have this bottom part, which is roughly in the shape of a cone. Its height is 1.5 meters. Its radius is the same as the radius of the rest of the tank, which is 1.2 meters. So we use this formula here to get the volume, just the same as what we did here. Just plug in 1.5 for R and 1.2 for H. If you do that, you will get 2.262 meters cubed. So to get the volume of the tank, we just add the cylindrical part onto both conical parts. So we just add this number to this number to this number, and we get 15.155 meters cubed.